Okay, well here we have an example problem on designing a ventilated improved pit VIP, ventilated improved pit latrine for a community that's a kind of crowded area, informal settlement just outside of Cape Town, South Africa. And the government in South Africa provides sanitation to its residents. So they've decided that a pit latrine is actually a good solution because of the crowded nature of the settlement, and they can't really put in any kind of sewer infrastructure. So latrines, household latrines are what they're going with. Okay, the design parameters here are that it needs to be built to last 10 years, so that's design life, and it's going to be used by a family of 6 people, so that means there are 6 users. We've kind of predetermined, because there's really kind of a set width, it can't be too large, too wide, because you have a certain, you're limited also by the structure around it, that can't be too wide either. So the typical widths for latrines are somewhere between 1 and 1.5 meters. So this one's going to be 1.5 meters. And we also can estimate for people in this part of the world and their sanitation habits that they're going to have an accumulation rate of waste that's 0.09 cubic meters. So that's the volume that's going to be needed to handle the waste for every person for every year. Okay, so that's the accumulation rate right there. So we have these different parameters are already identified. What we need really to be able to design this latrine is to figure out what depth it needs to be. So to what depth should the latrine be dug? And that's really the main part of the design. And we know we've covered this before, this equation, that the depth is determined by the number of users, okay, generating a certain amount of volume per year per user, times the design life in years, divided by the cross-sectional area. So this is like volume divided by cross-sectional area equals height or depth of the pit. Okay, then we need to have a certain amount of, save a little bit of space for the sanitary cap, which is usually 0.5 meters. Okay, so we can kind of give ourselves a little sketch here that we're going to have this latrine, all right, and it's going to have a slab here with an opening. This is called the superstructure, and this is a vent out which the air will flow. We're going to design it. If we were to really get into the details of the design, we would show a door here and maybe a little window or vent above the door that allows the wind, prevailing wind direction is, we're going to be facing in the direction of the prevailing wind. So that makes sure that that wind is kind of coming into the structure and kind of flushing all that odor out through the pipe. Okay, and it's going to be 1.5 meters in diameter or in width, and we're assuming a circular pit, which is typically what you will see, a circular pit. All right, and they're more stable. So here's kind of what it is. It's just we're figuring out the depth of this cylinder. All right, the pit is circular, so its area, this area of the circle is just pi r squared, and then the volume is just pi r squared times the depth. Okay, so let's do the area first. The area, and then from the area, that's something we need to put into the denominator here. Okay, so the area is going to be pi r squared, and we know the r is actually the width divided by 2, or the diameter divided by 2. All right, so the radius is just half the diameter. Okay, so pi r squared, and that substitute in pi times this number, 1.5 divided by 2 squared, is going to give us 1.77 meters squared. That's the cross-sectional area, looking down the plan area. Okay, so we're going to substitute that then into this equation for the pit depth, and now we can calculate it. Pit depth equals 6 users times the accumulation rate times 10 years divided by the area we just calculated plus the sanitary cap. Okay, so the pit depth then is going to equal this term here, which is 3.06 meters when we solve for that. Plus we need to account for a little bit extra for a sanitary cap, and then we get a pit depth of 3.56 meters. Okay, so that will look like this. This will be in total, this will be 3.56 meters And there's going to be this 0.5 meter cap where we can place some soil to cover over the contents of the pit latrine. Okay, and there is our example.